is we have an easy way to manipulate our data, and we define what's called a data frame. What we do is we read in our data and then we integrate it into data frames that make it easy for us to analyze and to chart. Okay, the data set that we'll be using is this one here, so it relates to healthcare information in the US, and the data set is in the form of a CSV. The first thing we normally do is to be able to read in the data set into a data frame object. So in this case it's called ver, and we're reading the df.csv file. This will allow us to be able to analyze our data. Okay, so let's have a quick look at what our data looks like. Okay, so the data itself is related to US states, and we have things like infant mortality rate, heart disease, stroke rate, death rate, and so on. Okay, and what we really want to see is whether we can show a trend or a correlation between the data that we actually have. Okay, so we're going to be using a number of Pandas methods to be able to analyze our data. Okay, so let's make a start on that. Okay, so one of the first methods that we can use is the head command. So if we just want to have a little peek at the data, so say the first 3 rows. Okay, so it's organized in rows, and there's an index value, and then we have a number of columns. So we can see in this case, if we just go for the head 3, it just gives us the first 3 rows of our data. And if we go for tail 3, it gives us the last 3 rows. So in this way we can actually just have a little peek to see what the data actually is. So we'll just give that a try. Okay, so I've just set up a little Python program here. Okay, so we'll read it in, and then what we want is head 3. And let's go for tail 3. Control X, yes to save, and let's run that. Okay, and we should be able to see that we see the first 3 rows here, and then the last 3 rows here. Okay, another parameter that we can actually use is to find the length, the number of rows that are in the data set. So we can use the len method to be able to look at the number of rows in the data frame. And another useful property is the dot columns. So the dot columns will be able to give us the details of all the columns that we can actually use. So it's very important that we know the names of these. So we can either use the names, or we can actually use a number. We have 0, 1, 2, 3, and so on. But normally we would use the names because that is better for documentation purposes in the program. Okay, so let's go back to our little Python program again. And we'll just do columns. Just get rid of that line there. we have. Okay, so we have region state. The spaces matter. So when we're referring to our columns, we need to make sure that it's exactly as it's defined there, even if there's any spaces at the end. Okay, so we can also look at the data types. So it will automatically cast the data for us in terms of floating point values, integers, or if it's a string, it will say it's an object. So var.datatypes property actually will define all the data types used for each of the columns. We just need one value not to be of the type defined here, and it'll actually change it to an object. So how do we list our values? Well, we put them in square brackets and we can actually list them out. So in this case we're listing out the region states column, and we can also do the same for infant mortality column there. Okay, so each one has an index value, and the index value is shown at the start there. That's the unique index that each of the rows actually has. Then we can list multiple columns. We put that in this time in the two brackets to define our new data frame. So in this case we're taking region state, infant mortality rate, and disease, heart disease, death rate, and we're printing them out one at a time. Okay, so for mathematical functions we can use the describe. So the describe will try to map it to a normal Gaussian distribution. So it'll actually tell us how many values there are. There's 52 values then. It tells us the mean, the standard deviation that it's fitting to, the minimum value, the maximum value, and then the different quartiles that we have. Okay, so this, if our data is in a normal distribution, this will give us our basic statistics for it, for the data. And this gives you an example of what a normal distribution looks like. So normal distribution will occur in normal life, such as for an IQ or for heights of people. And what we normally get is an average, or a mu, and a standard deviation, or sigma. Okay, the sigma value gives us the variation in the data, and the mu gives us the average. Here's one here where we have a mu of 5 again, but the sigma is only 2, so we see a much thinner distribution. We can see that this is a longer distribution and this is a thinner one here. Okay, we can also sort. So when we sort, we can sort in terms of our data set. So in this case, we sort for the lowest value for infant mortality, and it'll sort our records. So it's taken 22, 16, and then 46, printing the first three rows there. Or we can do it in ascending and descending order. If we have the extra property of this method, it will actually sort in terms of the infant mortality rate. A powerful function that we have inside Pandas is the correlation. So the correlation will take each of the properties and then match them against another one. So each value will get matched against the other values. So obviously infant mortality rates is correlated directly because it's the same parameter. But as we can see, the other ones, heart disease has a correlation factor of 0.718922 with the infant mortality rate. And it's this value that we use to be able to see if we can find a correlation between the values. And so what we find is that it's using the Pearson coefficient, and it measures the linear dependence between the two variables. We can see here this has a negative dependence. -1 means we can fit an exact straight line to it. If it's +1, then we have a positive correlation. If we increase the value on the x, we increase the value on the y. In this case, if we increase the value on the x, we decrease the value on the y. That's a -1 and a +1 correlation. We normally get somewhere in between where we fit a linear relationship between the two, either a negative slope or a positive slope. If we have a value of 0, then it's a completely random data set, and we can't really fit a linear equation to it. Okay, so if we look at the values that we had, this was quite a strong one, 0.7755534, and this was quite a weak one. So we can actually see when we plot the difference in the trends. We can see here it's almost you can see the trend happening there, but over here it's a bit more random. There's a slight trend that we have, but the correlation quite isn't as strong. If we actually try and open up that trend, let's have a look at it. Okay, so there's the infant mortality rate, and let's look at stroke death rate. And there it's there. Okay, so the state with the highest infant mortality rate and highest stroke death rate is Mississippi, and the lowest one is Massachusetts, Connecticut, New York, Arizona, Wyoming, and so on. Okay, but very much as we increase the infant mortality rate, apart from this one as a slight outlier, then we can actually see an increase in the stroke death rate. And this is the equation that we use. So we, if there's a linear relationship, we draw a line, a straight line, and the equation is y is equal to mx plus c, where m is the gradient, and c is the point. The m is the gradient, and c is the point that it cuts the y-axis. So the gradient is calculated as the change in y divided by the change in x. So in this case it's 2/6, which is 1/3. And the point at which it cuts the y-axis is 1 in this case. So this equation is, this line is equal to 0.33x plus 1. We can also run some other statistics on it, some regression statistics. And that will give us the basic equation for this line here. So this line here is an approximation of the trend, and we can plot certain statistics. There is the R-squared value. R-squared value gives us an understanding of how well correlated our data is. We can also look at this data here. So you can see that R-squared value isn't quite as strong in this case. And if we want, we can correlate 2 or more values together just by inserting them into little square brackets. Okay, so we need the 2 square brackets to build the data frame back again, and then we can add the correlation to that. So that's just taking the infant mortality rate and heart disease there. Then we can have what's called a covariance, and that looks at the strength of the correlation between the two variables. So we can actually see some strong relationships here, typically there, and a strong one here, fairly strong here, and so on. Okay, so the covariance is a useful parameter for actually seeing the strength of the relationship between the values. So let me just show you that. Okay, so what we'll do is let's go for the correlation first. And the covariance. Okay, so there we go. So in this case, if we look at it, if we could scroll up, we should be able to see the correlation, and then we should be able to see the covariance. Okay. So we can actually see there's a strong correlation there. It's a very large number, where this one is much smaller. Okay, so e times 10, the minus 1 is quite a small value relatively, where to the plus 6 is actually a large value. Okay, so we can filter our data, so we can use the greater than, less than, or equal to. So in this case, we look at the values which are greater than 4.8, and it gives us true or false values then. We can also rebuild the data set. So if we take the values that are greater for infant mortality rate for greater than 7 and rebuild our data set, we see that we get our values recreated, and in this case all the values that we have are greater than 7. We can also use the AND or the OR logical operators. So in this case we're printing for the infant mortality rate greater than 7 and greater than 45. So if we look at the stroke death rate here, we see the values are all greater than 45 and the infant mortality rate is greater than 7. We can do a count of the values. So in this case we're going through the infant mortality rate, and we find there are 4 values at 6.4. So those are probably those values here. For 6.5 there's 3, and so on. Okay, so this method allows us to be able to count the number of values that we have. We can also look at the number of unique values, and it'll give us a list of them. So in this case we have 8.6 and 8.7, but there isn't any 8.8. Then we can rebuild and we can create new data frames. So in this case we're taking together our infant mortality rate and the heart disease death rate, and remember it's the 2 square brackets, and we're building a new data frame, and we can see that we can print that one out, and it's only got 2 columns in it. This is often what we do. We often take columns and splice them out and create a new data frame. And in here we can see that what we're doing is sorting on the heart death rate there, and we can see there that is an ascending order now for our data. Then, if you can't remember the names of the columns, we can actually name them 0, 1, 2, 3, and so on. So with the one that we had previously, we had to give the name, but column 1 is this column here, This is column 2, 3, and so on. So in this case, we're just taking column 1 and column 2. We print out the 2 rows, and this is column 2 and column 3, which is heart disease death rate and stroke death rate. Okay, so that's been a brief introduction to Pandas.